get you to be my patient? So it has, like Adam said, it is my first talk in a long time, which means I'm going to do something clumsy before the talk is over. I'm going to knock over something or trip over something, just didn't see it. So we're going to be agile. We're going to be adaptive. We're going to have great results. We're going to work in the order that business wants us to. We're going to deliver business value in the order they want us to, which isn't really very convenient for us all the time. So we talk a lot about what our process wants to be, how we want to be iterative, how we want to be adaptive. And that's great. In the very early days of extreme programming, people like me were running around being very excited about how this all new world is going to work. And then there's some older, maybe wiser people sitting back saying, that's not going to work. You can't just run willy-nilly and change things late in the game. Well, it turns out that some things we can't change. We can take some very concrete steps in the way we approach technical problems to make our code or architecture easier to change later. We can simply put off some elements of our application until a later time when it's more convenient to talk about them. So during this talk, I want you to suspend belief for just a little bit. Let's pretend that we have complete control over our development environment. We have complete control over what tools we use, how our team's going to work, and just take it from there. How would we build things? And at the end of the talk, we'll come back to reality, and we'll talk about where things like organizational models start to hamper us and slow us down, and see how that affects us. Just a little bit, just to see how to get a hold of me later. So I'll be here at the conference the rest of the day tomorrow. I don't blog a lot, but my older blog posts are still up at codebetter.com. So I've been very involved with open source software. These are some of the tools that I've worked on. A lot of these are up and going today in production systems. In particular, I'm going to be using FubuVC as an example today. I'm going to show some of the things we're trying to do to get really good reversibility in continuous development. I'm not really trying to push the tool on you. I'm just using it as an example. More importantly, from all of these experiences and having other developers use them and building production systems on them, some things have worked very well. And some things have turned out very well. But the things that have turned out well, a lot of them are second, third, and even the fourth iteration, where we've gone back over something, where we've taken feedback from usage. We've gone back over it and improved it to the point where it's something that you would want to use. It didn't necessarily start out as something that was good, but we got there. Most of the stuff, most of the elements of FubuVC that I think are very good right now were built for a very specific need. I didn't sit down and say, hey, this would be cool if we did this. It started from, I have a need on a project I'm working on now. Building it, getting immediate feedback, improving it as I went. On the other hand, some things aren't so good. One of the things where I've taken the idea of, wouldn't it be cool if we built this feature? Wouldn't it be cool if you could do this? You could build all kinds of great things in one. And just started from conjecture. A lot of these things are the fun things to build, but they have a very poor track record in the real world. Because I was guessing what was needed. I didn't really know. It didn't really fit the bill. Other things. Some other things just aren't good yet because none of the people have used it enough to kind of grind it down, to find the problems, to smooth out the usability problems. And in one particular case I can think of, we have conventions in FubuVC. So you can take any given controller action, look at it, and resolve what the URL should be for it. Seemed like a great idea at the time. The code in there that does this today in FubuVC, the original code, I've never liked. It's not very good. It's 3 years old. it's hard to change. And because it's hard to change, I've just punted and left it alone, left it completely unseen. The code is not great because it's just flat out too hard to change. So I want to start off two quotes, and I bet you've read these before, but they kind of form the basis of what we want to talk about here today. So this is Mary Poppy talking about the last responsible moment. The story she tells about this, or the analogy that I've heard her tell, is pilots are trained to first decide when they're going to make a decision, when they're in some kind of emergency. The plane is stalling. You're losing altitude. They're taught not to panic, to try to hold on and get a little more information about how the plane is handling, and make that decision of, am I going for the ground, am I turning, whatever it is, at the last possible moment they can. Because at that moment, that's when they know most about their problem. And what I found in my open source work is this is very much true for me. The coding work that I've done up front, wouldn't it be cool if you could cache like this? That work has not always gone on to achieve very much, because I just didn't really know how it really needed to be used. If I maybe waited to build that until I had a real world case for it, maybe it could turn out to be a lot better. So another quote, and I don't see this nearly as commonly, but I think it's very important. But basically, what I think Martin's trying to tell us here, the decisions that we just can't get wrong, the things where we can't change our mind, we absolutely have to get those things done up front and immediately. We can't wait. And that's fine, but that makes us brittle. It means we have a lot more things to worry about. What if instead we can make a lot more of the architectural elements of our system, whether it be authentication, authorization, how we're going to do validation, how we're going to display this data, how we're going to store data. What if we could take some of those architectural needs and just push them off, not worry about them now? What if it were cheap to add those things later, just so that I have fewer things to worry about on day one of a project? So from a talk, I read it first from one of Martin's articles, but I think someone else originated it. The idea of reversibility. How easy is it to change my mind about a decision? Right? So the rest of the talk, I want to get into technical strategies and just the old-fashioned design principles that we can use to make our architecture a lot more reversible. Because if we can make it much more reversible, we've got less stuff to worry about at any one time. We're more likely to be able to use the things that we learn later on in the system to improve our system, rather than being stuck with whatever we happen to decide in iteration one. Can everybody make out what this is? Is anybody not familiar with what this is here? So this is the very beginning stages of constructing a house using a concrete slab floor. So what you see there, the crisscross, it's rebar, but more importantly, these pipes that are sticking up here. Plumbing, conduit pipes, whatever it's going to be. Those pipes absolutely have to be in the right place for wherever the bathroom's going to be or the kitchen sink's going to be. Because once that concrete's poured, to create the concrete slab floor and the foundation, you're kind of stuck. You have to be bright. They have a very low reversibility here. And you might ask, why did I choose this example? As a much younger man, I used to work with my father's construction crew in the summers. So you got to picture the most miserable, hot, humid July day you've ever seen in your life. Now I'm just kind of casually running around, carrying boards around, trying to look busy, not trying to work too hard. The poor plumbers that have laid out the house, they put these pipes in the wrong place. So they had to come out with a two-man crew with a saw that was bigger than the smallest of the two guys one guy pouring water over the saw, the other guy with the saw with a blade like this, cut through the concrete, move the pipes around, pour the concrete, smooth it all down. Just the most miserable July day you could ever think of. And they did it wrong the second time too. But that's what I've always thought about. When you talk about architectural reversibility, we don't want to set ourselves up to fail like this. We don't want to have to be like construction where our pipes absolutely have to be perfect and we can't change our minds. Because we can't make any mistakes that way, and you're going to make mistakes. So, we all agree low reversibility is fragile. You're not going to fail every time, but if you have very low reversibility, you're a lot more likely to fail. So how do we increase reversibility? How do we make it possible to put some of these big decisions off? And the first thing I'm going to say is this absolutely has to be a first-class citizen in how we choose our technology. Is anybody else a veteran of Visual Basic programming back in the day? All right, there's some of you. So I've taken a poll from the people that I've met that have done Visual Basic. And all of us remember doing the same thing. You couldn't actually, Visual Basic didn't support a stack trace. So you would always write this little bit of extra error handling at the bottom of every single method to fake a stack trace. At the bottom of every method too, you have to dereference every single variable that you declared somewhere up top, or you'll have severe memory leaks and things are bad. You don't have built-in garbage collection. It's a lot of ceremony. It's a lot of things I have to do. And if I have to do this on every single method, once that method's written, I don't want to change it. Right? I'm not likely to want to evolve the system. If I made a mistake in there, or if I simply come back a week later after we built other code on top of it and realized we could have done this much better if we'd done X instead of Y. I'm not very likely to go try to improve that VB code because it's just too much work. So even worse, it's rare these days when I see anybody say the word calm without appending hell to it, right? Or if you follow my Twitter feed, you probably also noticed that I rail about strong naming, strong named assembling in .NET quite a bit. So in the context, if I change the public signature of any class in one of my COM components, recompile, it is automatically incompatible with everything else that's ever been compiled against it. So if I go into an upstream component, and I change something, everything downstream is completely broken. To the point where, at some points it got so bad, you would have to go into your Windows registry and go dig through and find the GUIDs in the registry high. Anybody else besides me remember doing that? Yeah. That wasn't much fun, was it? So what did you do? You tried really, really hard to get the signatures of your COM components down pat very early on. Maybe you did a lot more paper design than we would have done today. You wouldn't want to change your COM components. And because you couldn't change those COM components, you wouldn't even try to evolve your system. And that's great if you get everything right up front, but you won't. And even if you do, your business people are going to change their requirements a couple weeks later, and it's not going to be valid anymore. Or 6 months from now, they're going to want to build a feature that nobody had envisioned before. But it's hard to change, and that's still fine. Okay? I'm going to pick on databases a lot in this talk. Is anybody still doing development with stored procedures? Okay. I'm sorry. Anybody still using ORMs? Well, actually, I would expect a lot of people to. It's just kind of working down from less reversible to more reversible. 10 to 12 years ago, almost all of my development would have been done doing all my data access through stored procedures. Let's say I want to add a field. I want to add a field to the system all the way from the database to the UI. Kind of genius. I have to go, at the time for me, I would have had to go and change 2 to 3 different sprocs. and add a field to this proc, add one to this proc, add input parameters for all of those. Maybe go check the select input, the selects of several other read-only stored procedures. Does that sound familiar? Moving forward. Oh, no, still go on. When I move to object relational database mappers, right? At this point, I'm not really writing smart procedures. I'm probably not writing a lot of SQL per se. Now when I have one field, if I add one field, let's say we're doing all of our ORM configuration explicitly, I go in one place and I make the mapping. This field goes to this property on the object. So I've shrunk down from 3 or 4 places to 1. And I still have more work to do because I have to go to the DDL itself and remember to put in that, hey, there's a new column. Add a new column, a database migration, whatever it is. I've still got some repetitive work, and that kind of slows me down. Making it to the third step. So my last project, last year, for about 9 months of the 11-month project, we ran completely in memory. Just fake the database, just said, we've got an in-memory storage, don't worry about it, we'll come back to it later. At some point very late in the project, we used RavenDB, that's a document database. And it took me about a week and a half to get it retrofitted in, get all the tests fixed, but it kind of worked. And what I found, and what I really like as a positive with a document database, is anybody using a document database? Or key value stairs? Okay, great. We were running schemaless. There was no DDL, there was no mismatch. Effectively, all we were doing was serializing our objects through JSON and stick them right in the database. Hierarchical data, no problem. Polymorphic data, where you have lots of different subclasses, no problem. All that work that you do with ORMs, to do all the collection mapping and split across these tables, and the very tedious work to map all the subclasses of something. All that went away. As long as it could serialize, I was good to go. At this point, you can do things like, if I want to add a field, to the screen, the UI, the database, the model, whatever, I go to the model, I use my little resharpen shortcut, I add it, and it's just there. I didn't have to do a database migration. I didn't have to update my DDL. I didn't have to update mappings. It just worked. It just flowed out of my model. When you get to that point, or even better yet, when we start with the in-memory database, changing my model, getting my business model right, that stuff is very soft because there's not a lot of collateral around it. It doesn't hurt me to change things. It made it very easy for me to kind of grind away, to evolve, to optimize the way that model was going to be. And it helped us tremendously. At that point, taking on some new features, changes to the system, it wasn't that bad. We could do it. Any questions about that? I mean, I will be around in the next session. And please do interrupt me anytime.
More ends and the dimensions, so change in the details.
So, let me get that in a later slide. I'll come back to that. Conventions, I'm going to do have a slide for conventions.
What about data integrity?
About what?
Data integrity.
Data integrity?
And force through.
So, my take on it, what we did find out is we did slip up occasionally with things like unique constraints. Things like the old-fashioned not, that's not what I meant to say, not nulls, maximum string length, those type of validations. Those things were handled very easily with just the normal validation you have to do in your system anyway, right? It's very unusual that your database is the only place you're doing that validation. Do you agree? It would be unusual that that would be the only place you would do it in your system. So the normal validation we did. This field's required, these business conditions have to be met. That validation did most of the work to stop bad data from getting to the system anyway. The place where we did slip up, wasn't that obvious to me at the time was things like unique constraints. That might be a little extra work. But what you end up doing is you move that functionality completely to code-based validation.
So basically, you're getting the numbers and changes in the database, and also change the business rules without knowing, and then that garbage to the database.
We didn't. Your validation rules are in one spot. Validation rules are in the code, and that's all locked down. There's another issue here too, though. I'm not completely antagonistic towards a relational database, just mostly. I've got a lot of stripes left over from Oracle's 734 and the whole bit. But so the other advantage is validation rules, especially if they're code-based, they're very simple to put automated unit tests against those. Use your acceptance test. You can do that against a database, but it's higher friction against a database than it ever would be against the code. The code is softer than the database, I think is what I'm trying to claim here. But no, you are correct. You have to take care of the validation. Choose a validation framework that is very declarative. It's not that different than making your constraints in your DDL. Is what I'd like to claim.
So maybe one more question. We'll use this time. I think we got it figured out. When you're okay with that,
All right.
to me. And maybe we can address the convention dates for and stuff.
Okay. So in terms of conventions, is anybody using Ruby on Rails right now? Or actively using it at work? Okay. So Rails blew me away when I saw it for the first time, 05, 06. Just the coolest thing I'd ever seen. From an architectural standpoint, the best thing to me about Rails was this whole idea of the don't repeat yourself idea. I'm not exactly going at the question you said. But the important thing here is there are facts about your system. There are these many fields in a logical entity. These fields are required. These fields have this type of aspect to them. I want to say it once and only once. In the Rails world, using Active Record, you're really defining your database. The database is the true model of the world. The code in this case is a perfect reflection of the code, right, of the database, right? So this model we might have had in Hibernate or Entity Framework a couple years ago, where I had these completely parallel models, database tables, and in-memory representations. Completely separate models, and I had to map the two of them and kind of maintain them separately. That's drag. Rails coming in gives you this idea that this don't repeat yourself idea. I keep up my database migrations, and the code just matches it through runtime. It's all meta-programming, right? We took it to stay in the C# world, took it the other way around. And again, I want to work in a code-based model. I want to use a deep object graph. So let's say now that the code is the master representation of the world. All those facts, not null constraints, maximum length validation rules in the code and the model itself. At that point, we started to generate the database from our model. Is anybody familiar with Fluent in Hibernate? Or the Code First Entity Framework that just came out? Okay. For those of you who aren't, this form of an ORM, they both have some meta-convention features where you can create some rules that kind of tell the ORM, how would I generate the DDL for this model? Knowing things like, for us in a previous project, we tied into the validation subsystem plus our model. So we could say on our model, this field is required. And we just use an attribute, just a required attribute. But from that attribute on that model, our DDL is generated from the model, so we get a non-null constraint on it. The required attribute also drives our server-side validation. As you try to submit a form, and you try to submit something with a missing value, the validation is going to fail because you marked it, declared it with just that one little required attribute. Client side, we would generate what we call HTML conventions. We would be generating just element by element, a little micro generation. We would generate the HTML for that one form element pointing at that one property on that model. It could read the metadata from the validation and set us up with client-side validation using something like jQuery.validate.js. The point is, we were able to express a fact about the system in one place and make it active throughout the application. And that's really important. Well, it's important because it's just less work, period. But it's really valuable because I can change which fields are required, not required. I don't even really have to worry about validation up front. But I'm just trying to worry about getting the UI to look what it needs to look like. I can forget all these things like perfect validation and database constraints. And these things, all these T's and I's need to be crossed and dotted in the end. But I can put these things off, keep things very soft and malleable while I figure out how things need to be and get feedback from my users. Does that answer your question, Adam?
Yep.
I do have a code sample of how conventions work here. I always like this phrase, the wormhole anti-pattern. I'm using a lot of CRUD and database-based examples, so let's just keep on doing it again. You're in your stand-up meeting and someone asks you, how much would it take to add another field to the screen? Right? We have techniques today where it's not that big a deal. But if we rewind back to the way that I would have been developing maybe in 2000 or a little bit later, it's, I got to go to a SQL script. I've got to add this column. And then I got to go change these 3 or 4 stored procedures to add this column. And then I might have to go to this model object and change something in my domain model. Or I might need to go into AutoMapper and change a field on a DTO. Or I start to have all these steps and then finally get to the screen. Or really repeating the same little bit of information over and over and over again. So I had some older colleagues, and I don't really have older colleagues anymore, but I used to be younger and have older colleagues. When an issue like this would come up, they go, we'll just have to go all the way through the wormhole again. So, bring it back. Fast forward to 2012. Like I said, I prefer to use document databases now when I can get away with it. With a document database, I add my field in my class. And since it's completely additive, that's actually good enough. I'm done with persistence. I might go do a quick check, might go change my unit test to make sure that that property is really being persisted. But as far as persistence is done, I'm probably done. Because persistence, the logical schema, is completely reflected from the model object. I use my refactoring tool, my IDE, I add that property. I go into the screen, and depending on how you set things up between your controller service layer and your UI, my bias is let the UI screens, let my Razor or Spark views go ahead and know about the domain model or whatever the persistent model is. Maybe you go through a DTO translation layer. If you're doing something more like CQRS, there's more stuff going on there, but it's still far less than it would have been 12 years ago. By shortening up the wormhole process, how many repeated steps we have to do just to pipe one piece of data from database to screen to queue to whatever it is back again, we can move a lot faster. And we're more likely to want to absorb changes on later on. So I think I've already talked about this. Once and only once. I mean, these are really 2 different ways of saying the exact same thing. But once and only once. To review. That example I was trying to make of using the validation attributes or the validation rules and have database definition language in one way, client-side validation, server-side validation, and even the way that an element was displayed on the screen. A little color coding of, so it's a 2-page app. This page and the page behind this link right here. So, say you have screens in your system, and you need to throw in role-based authorization later on. That role-based authorization, if the user's not really allowed to be there, you throw the 403 status code, forbidden, you can't go here, go away, right? And at the same token, you probably got some kind of navigation bar somewhere with all the options, all the places you go in the system. Those same authorization rules will govern your navigation menu items. Should be hidden, disabled, whatever it's going to be. But it's the exact same business logic, right? Is this something that you would hit in your systems day to day? So let's try this example. And I didn't exactly check this one out ahead of time, so this could be the mess up fun. Okay. So I'm going to add authentication to this thing real quickly. You're laughing at that. I left it off on purpose for a minute. And now when I open this up, it should take us right to a login screen. And it says, yeah. Okay. I'm going to come back to this, but I added an assembly reference. And now we suddenly have a login screen coming up. Anybody notice that? We're going to come back to it. I'm going to talk about the open-close principle. But this is the best possible example that you have to do. Who's heard of the open-close principle, or solid in general? All right. The idea of the open-close principle. Any piece of code system, you ideally want it to be open for extension. You want to be able to add new behavior, add new look and feel, change the system, but you want the code to be closed for modification. And it sounds like a paradox, right? I always thought so. A lot of times I've seen this construed, especially in the .NET camp, is that means we can pull out an interface for everything, put an I in front of that, and maybe we can throw it away and we'll plug it in later. But what it really probably should be, the way that I think we should interpret this and to take it to heart, I want to be able to add behavior to a system, add new functionality to a system by writing all new code rather than going in and changing old code. If you had your druthers on a daily basis, what would you rather do? What's less error prone? Would you rather write all brand new code off to the side or try to get into some kind of complicated existing code without breaking it? Who wants to write new code? Yeah. Who would rather muck around with their old code? And even if it's code you wrote yourself, I don't even want to get into my old code. I got to get this away. Okay. So this is an example of the open close principle. I'll even show you a little bit about how we pull this off. Okay, so we're back to that same screen, current time, we got a link here. So the next thing I want to do is, I'm going to go ahead and add some authorization to this thing. We're getting some. Okay, let me shut this thing down.
Jeremy, no need to rush. We're going to go a little bit late because of the technical difficulties. So keep that in mind if you're trying to rush through.
Oh, I don't know if all the people wanting to get done out of here like the sound of that. All right, so this one piece of data, this one screen that's going to show you the current time, it's just this one little endpoint right here. It's real simple. It's doing nothing but telling you what it's now. Well, let's just go declaratively add some authorization rules to it. Just to defend FUBU, you don't have to do this through attributes. It's just a quick way to do it for me right now. But let's just say, it takes in role 3. Now I'm cheating a little bit. I'm going to say that every user that gets logged into the system, let's just pretend they have role 1 and role 2. So they do not have role 3. That's all right. So when we log into this thing again, we should be able to go to that current time screen. All right, so there's a reason why my teams don't let me do UX work. That is true. We have better menu controls. But that dot right there, the link that's supposed to take you to the time element, doesn't show up at all. Right? And moreover, if I try to, if I try to go to it directly, I get this 403. Right? I only made one change in the system. I just declared this endpoint requires this role, but that knowledge expressed in one place works in both places. So looking back at the real code again now. What I didn't show you here. Okay, so you see this code right here, the link to. Link to the endpoint class, that method. So what I've declared here is I want an HTML element link that points at whatever the URL happens to be for that thing right there. And then some extra text. So built into FUBU, we had an application where we had a lot of very fine-grained authorization rules. Spent a couple of months building all kinds of crazy, turn this thing on and off, whether a user has a role, none of which turned out to be useful. That was marketing as well. I think some of it might actually be useful. But this link to helper, this HTTP helper, it's aware of the authorization rules that we apply to that one little action. So, the same kind of token, we normally do this kind of work. Show you real quick. So, obviously a Twitter Bootstrap kind of application. So this menu bar across the top, application startup requests, routes, whatnot. There's no authorization rules on this piece of it, but that navigation bar there is built off a model. These are the endpoints I want to be pointed to with the menu text. That navigation helper is aware of the same authorization rules that we put on the actual endpoint. So express the authorization rule one time, and it just flows through. Does anybody see how this could be valuable in your system? Okay. So what I would say, the most valuable thing about this, and it's what I've experienced, is when I start my new system, I'm starting iteration 1 on Thursday when I get back home. We're not going to worry about authorization. We're not even going to worry about authentication. So just see that I was able to apply authorization with one little attribute to an existing endpoint. And you saw that that flowed through the navigation. So I'm not going to worry about authorization in front, because I know that it's not very risky for me to go stick this stuff on later. And I can do a lot more than role-based security. I can do any kind of logic role I want. It's a plugin model. So when I get to my new project on Thursday and we start, there's parts of the screen, parts of the application that I'm very worried about. It's going to have a very complicated look and feel. The UI mechanics are going to be pretty complicated. It's going to take a little while working back and forth with our analysts to know, does this workflow, the screen workflow, really help you solve your problems, your work, easier than it does today? And of course, they're doing a very paper-heavy, intensive model, so anything we use can work. But still, the project risk is in the user experience in this case. I don't really care about the database. I don't really care about authentication or authorization as much, because I know I can change my mind and add that stuff on later. We absolutely have to do it, but I'm going to shut it off and forget about it for now. Right? So do you see how that just gives me a lot less to worry about? I can start my work. I don't have to figure everything out up front. Any questions about this?
If you need to do access to data, let's say a user who has role 3 can access to data A.
Getting more of the, instead of screen by screen, getting more of the
Yeah,
data.
let's say we have company management system, and your system is multi-tenant system, so you have companies A, B, C.
Sure.
And certain users should have access only to data of company A. Of course, this user should have role that access.
So, does anybody here follow Iandi's blog? Oranini's? Okay. I'm going to say some things that are really going to offend Iandi, but he's not here, so if you guys can relate it to him later. Oran's been on this big kick of too much abstraction is a bad thing. That's fine. A little bit of abstraction can be a good thing. So, in the exact scenario you're talking about. So, take a look at this interface right here. Just a generic repository. The way that I like to use a repository interface is I like to have one interface that can handle every type that's persistent conflict. Okay? It's a big philosophical argument about whether you use repositories at all, whether you specialize in each kind of T. This is the way I like to do it. And for most things, this is good enough. For most things, I've found that it's perfectly good enough to just get a queryable, tag on a bunch of link wares. I am going someplace with this. So, the 11-month project I just rolled off of, we use this interface most of the way through. About 9 months of the time, this is completely in memory. At about 7 or 8 months, we finally said, I need to get multi-tenancy in. Right? Same thing, kind of scenario we were talking about. We had multiple sites, and either by user permissions or just where you want to look at, you only wanted to have one site active at any time. So only show the records for that one site. So what we did in this particular case, we hid all that behind this interface. So this queryable here, where I would query whatever the T's happen to be, behind the scenes, if it was a T, if it was an entity type that was site aware, something that had to be governed by multi-tenancy, behind the scenes, I just quietly tack on where the site ID equals, we had a service that would tell you what the current site was. Do that behind the scenes, so that fact was only really known in one place here. And then we also governed it on things like the update, remove, find where. It wouldn't let you get to data from across sites. But you hide that multi-tenancy. We got away with hiding behind this interface. So we coded we coded 2/3, 3/4 of the project before we introduced multi-tenancy, which was a pretty big deal. Now, the system wasn't going to work without multi-tenancy, but we were able to pull it off. So I think what I'm trying to say here is putting all the data access, all the persistence behind one common spot. And we did have to go around this when we hit heavy-duty performance things. You had to go around it you had to go down it with different abstractions. But most of our data access could be done with this. So it was relatively easy to go to this one place and make it smarter to deal with multi-tenancy in one place. Does that help? So if I were doing this with an ORM, or maybe with maybe it was Sprox back in the day, I think I'd be looking for a convention-based thing. Say that all your tables or all your entities that have to be site-aware, tenant-aware, that if you see a tenant ID or tenant on that object you're trying to query or that table, that whatever your gateway persistence is can be smart enough to tag on the extra where clause or the extra ORM query clause. That's how I would be trying to deal with that. And that is how we dealt with that issue. Any questions on that? Now, I'm not sure I would say put off multi-tenancy until month 10 of 11 again, but we got away with it. Okay, so you just saw me add authentication and authorization to a running application and a running screen without going in and changing that screen. Does everybody agree and let me get away with making that statement? No tricks up my sleeve? So the question is, how do we get away with that? Right? Let's look at that same screen again. But let's look at it a different way. Next time I'll bring the fast box. Okay. So, Reversibility. It's based around an architectural idea, a runtime, that I like to call the Russian doll model. I can't say the real name of it, but if you can remember what the Russian dolls look like. There's a little doll that's inside a slightly bigger one, inside a slightly bigger one, so on and so forth. I think most of the REST frameworks, or most of the HTTP service frameworks that I'm seeing come up lately, Web API from Microsoft, even WCF, way under the covers where you can barely see it, they have this, to some degree, they have this idea of the Russian doll model. So same thing here. On the outermost part of the runtime, there's an authentication behavior. Behavior just being a food term. All authentication does is check, is this user authenticated? And if they are, I'm going to continue to the guidance inside of it. Inside of authentication is authorization. I have some certain authorization rules. Does the currently authenticated user match these authorization rules? No? I'm done. I'm going to forward you, I'm going to throw a 403, steps go 403, you're done. Don't go past go, don't collect $200. But if you do pass authorization, you go inside. And now we get to the actual action. Right? If you're anybody using ASP.NET MVC? Okay. Then I won't contrast it here. So I run that action. And get its output. And then finally, the most innermost node is generate the view, render the view from the data. So when I wanted to add authorization and authentication, I take a completely new object and I wrapped it around it. So I never had to change anything about this code. That's an example, again, of the open-close principle. I was open to extending the system, but I didn't have to open up the code and modify it. Right? And the reason I get away with this is it's very compositional. The very distinct responsibilities, authentication and authorization, the actual action rendering it. They're all in separate pieces of code that just happen to work together. In a static type language like C#, this kind of Russian doll model works out very well. If I were doing something like Python or JavaScript, it might be very easy to say this method wraps this method. If I'm in Ruby, I may do that by pulling in modules. But the point is, I can compose these different responsibilities in different areas of the code to make them work together. With the strongest goal being here, I don't want to have to make every change in one piece of code. I don't want to change an existing piece of code and potentially destabilize it. I want to just add new things around. Any questions about that? Because I think that's really powerful. Or I definitely think it's helped us. So one of the things, maybe taking it a step farther, one of the things that makes us afraid up front, makes us want to get everything perfect up front, is this fear that it has to be fast enough. Right? So you're going to spend a lot of time coming up with the very quickest, fastest algorithm. You're going to design it that way. You're going to get halfway through the system and realize your performance problem is somewhere else. Does that ever happen to anybody besides me? No, that's all I answer. I did this to you, which was speaker. Being able to put off concerns about performance is another good reason for us to worry about reversibility, because it allows us to proceed without fear. Take this one endpoint. Start over. Adam, do you want me to start wrapping up?
Anytime I take a Q&A, we're on the dot, we're finishing, but we had some technical difficulties, so up to you guys.
Okay.
Take Q&A, whatever you like.
So I'm going to come to the end, but I'm around the whole next hour. So just to try to recap. Compositional approaches, where you separate your responsibilities, help tremendously. Being able to do things like take one part of the system and optimize it for performance without breaking the rest of your system. That's a huge amount of reversibility that allows you to progress with simplistic data access strategies that may be good enough. And you don't worry about optimizing them until you absolutely have to. But you away with it. The open-close principle. It's not just about interfaces. Can I write new code, or do I have to change old code? So I've said, pretending we're in a perfect world, we control everything. You don't control everything. There are things outside of your control that are going to decrease your reversibility. In these cases, your last responsible moment, it's not very late, it's not last, it's right up on you. Recognize the places where you do not have reversibility. You don't have to deal with that quickly. When I was a software consultant about a decade ago, I got on a project where we inevitably had to integrate with the nasty old legacy system through MQ series. Right? The only way to get into that system was to talk through another group, a completely different organization. They had a very strict calendar. You had to get signed up with them months in advance. This is the only time I'm allowed to collaborate with you. You have, in that case, you have very low reversibility with vis-a-vis that part of the system. You have to make those decisions up front. In that case, having reversibility in other part of your system will at least enable you to put off other concerns to concentrate on the things you have to get done up front because you don't have any choice. I would still argue that things like localization is a low reversible choice. It's not that bad to build in a localization mechanism up front. It's very tedious and painful to come back from behind and retrofit into the UI. Just my opinion. So even though localization is it's not usually a critical item for anything the business is concerned about, if I have to have localization in my system, aren't you guys required to make sure that everything's available in French in Canadian websites? Okay. So it's always important for you. So just gotta do it. The one time I did do a project in Toronto, it was right after the South Park movie had come out. And when the Americans on the team realized we had a new localization for this, because get back, we started singing the Blame Canada song. Your organizational model is going to hurt, potentially. So the highest reversibility is when you have a completely self-contained team with every possible technical skill set that you would need on the project. If you have to interact with, and just take an example from my career, I had a project where I had to interact with the people who ran the Redwood scheduling system. They're completely off the team. I have to get my stuff, my ducks in a row for them, because they need several months in advance of paperwork in order to do anything for me. I don't have reversibility with it. I have to figure out what the jobs are going to be pretty close to upfront to deliver to them. Teams where, and I've seen this pretty frequently, teams where you separate out the data modeling and database people from the developers, and you require all sort of procedure for all access. Developers can't run around and change their mind all the time, because they can't just run around and change the sparks all the time, because you're flat out not allowed to. I'm picking on the database again, but it's something that's very real. When you're interfacing with an external technical team, you don't have the same reversibility. You worry about nailing down those kinds of things first. Looking at maybe not purely technical things, your reversibility is obviously much higher if you have a very good project automation strategy. Automated builds, a strong defense layer of automated testing will make it a lot more likely that you'll be able to make later decisions safely if you have that really good safety net. If you don't have a good test automation safety net, you can't be doing things like turning the database on for the first time 9 months in. And even then, it wasn't that much fun. And of course, your other problem, just the people problems. If your business isn't involved, or they can only be involved in 2 weeks as you start the project, you just have to take it into account. You got to make decisions when you can. It's not ideal, but you still have to do it. So again, the things that you can control, if you make those as easy to delay as possible, maybe you can give you more time and concentration to worry about the things you cannot control up front and make your project less broken. So with that, I think I'm ready just to call for questions.
You talked about having a good suite of automation tests. Can you speak a little bit about what level you prefer those to be at? I know you're a BDD guy, but in terms of unit tests or integration tests?
So what level of test, the question is what level of tests you should have. Yes. I have one and only one rule of testing. And I was telling Adam about this before. You should test everything at the finest grade level of feedback that gives you a useful result. Yes, you want unit tests at class interaction, method, property level. I want lots of unit tests because it's a very efficient way to grind problems out of it. I'm still a very big believer in test-driven development at the code-centric level. There are some things where the only valid test is more of an integration test. Can I take this object and persist it? With multi-tenancy, get a test at the service layer itself, load data in with a bunch of different tenants, say the security is this tenant, can I get it out? That's a much lower level test than an acceptance test, but it's valuable. It tells me something important about the system. And yes, they're much more expensive, but if you can come back with a suite of more end-to-end tests, whether you're doing a BDD or acceptance test-driven development, or it's done a little bit after the fact, if you have a suite of tests that can drive the system end-to-end enough to prove that all the pieces that may be tested independently are connected together and the information can flow between them, that's when you're going to be safe. It takes every level of test.
So outside of localization, are there other examples that come to mind of things that you have had in trying to
Oh, yeah, great. I was going to make an example of this, and I ran out of time in the code sample. UTC, date handling. So I've actually got a bottle for Boo BC to just stick it in and do all your date conversions to UTCs coming up, going down to make sure that dates are always rendered in the local time. We missed that somehow on my last project. No, it should have been pretty obvious. We were very focused on these little simplistic data sets where everything was between midnight and midnight in one hospital in the entire world, and that's not true. Make sure your dates are stored in UTC, because that's spread all the way through the code. Anything that's going to spread through the code that's not something you can control in a centralized place, localization UTC dates. I think that you can control a lot of those low-level data entries, being very, very aggressive with the conventions. Pop in and looking at one screen real quick. I didn't get this example, but what I'm showing the current time is that both the model binding coming up to the server and then the display going down. All that is driven through conventions that display for. I'm going to display the value of this current time property on this model object. You can do a lot of different things there. You can do the UTC correction. You can make sure that you're displaying it in the exact date format that the system is doing. Do I want to show month, day, year, or do I want it shorter? Do I show the year at all? Driving very hard on conventions and more policies, I think will help tremendously with that one as well. And that's why we do so much of it in Fugu.
Jeremy, you mentioned interfaces, so it's probably a good way to do inversion of control, and then you also mentioned behaviors, like you use them as decorators. Is there any other patterns, design patterns which you use to improve the reversibility?
No, sorry. Well, anything that leads to separation concerns. So if we're going into UI itself, I'm doing a stateful user interface. And typically I have a native iPhone app. We're looking at patterns like model view percent. Right? I can separate out things where I can separate out the actual view presentation and how that works inside. I can separate that from the logic of when does it need to do the things it needs to do. In more classic web development, I'm going to be looking at that Model 2 style of model view controller separation.
Would you consider dependency injection as a killer of reversibility or opposite as a helper of reversibility?
It's valuable. I don't think I would say critical, but what I would say, dependency injection as a subset of inversion control. Yeah. Inversion control is very frequently a good way to separate these kinds of concerns. Taking another example, I've used this over the years several times. That was a good question. I remember this. I did several applications when I was a consultant or internal IT. We had some kind of very valuable rules engine. It's the rock star of whatever world that it's in. Makes all kinds of determinations, picks the most optimal route. And in both cases I'm thinking of, they looked at this rules engine as a huge strategic advantage. And they said, I want to be able to use these rules in a different context. I want to be able to feed what-if data to it. Or instead of using it in a back-end service, I want to now use it in a user interface somewhere off to the side. It would be very valuable if I could take these very valuable rules engines and use it somewhere else. But they couldn't. You saw that one coming. In both cases, the rules engine was very tightly constrained. The rules engine itself reached into, in one case, the MQ series to grab the data that it needed to, or grabbed into database structures to get what it needed. In the other case, the rules engine was tied to a really bizarre, one-off, homegrown serialization format. Right? But the key point is, this rules engine, this very valuable piece of logic, was very tightly coupled to the things that were around it. Because it was in control, it was active, it reached out and grabbed the things it needed. So if it didn't have all those exact same things it needed, it was useless. Now take that same rules engine, let's say we build it from the very beginning with inversion control. The rules engine doesn't call you to get stuff. You call the rules engine with, hey, I have this scenario of stuff. You tell me what I should do with it. Where should I route these boxes on the factory floor? What's the optimal way to, what's the pricing for this energy trade, right? So I can make gasoline be cheaper. Don't worry about where this data comes from. I'm going to tell you, I'm going to invert control. I'm going to push what you need to you, and you tell me what you can do. So that's kind of an example of inversion control outside of the typical dependency injection example. Very valuable way to get this kind of reversibility. Think of it as a Lego approach too. You know, I have smaller Legos. I can build a lot more stuff. I can rearrange them. I can do new scenarios we didn't think of at the beginning of the project. You guys ready for a break? I'll be here in the next hour.
Please stay behind, I guess, during the breaks, conduct the journey. And also please remember, if you've received a chip from Jeremy, you can redeem that for a book of your choice from the bookstore. And on your way out, please remember to vote for the session. There's baskets there, 3 baskets, red, yellow, and green. So please stick around as well if you want to conduct the journey. And from Agile Vancouver, thank you, Jeremy, for finally making it up to Vancouver. Some local art to put up on your wall in your office.